here in Delft, we have our third network-wide training event of the 6thSense Marie Curie training network. In this project, we aim to establish a training program for 10 doctoral candidates in Europe.
The project as a whole is focused on giving our mobile networks an additional eye.
Called joint communication and sensing.
That's a very important topic for 6G. That's also why we call the project 6thSense.
The signals that we have in the air are going to be useful not only to send information, but also to sense.
It's a chance, like a team building, to get to know your colleagues, to do some meaningful activities together.
And we all have our different expertises and things that we focus on.
Well, the past few days we have been having our network-wide events.
As a PhD candidates, we also present ourselves.
We updated our progress.
Well, the goal of this meeting is actually to get insight into what the different PhD students are actually doing, the research areas that they are working on.
It's definitely very interesting.
We meet the project officer from the Research Executive Agency of the EU, and we explain our progress so far.
We're almost halfway.
We've been talking about this already since 2021.
We are on the second year of the project.
Well, we have most of the candidates onboarded.
Still looking for one, but up to 10 excellent PhD students.
I'm Hussein Ali Abdul Hadi Al Hakim. I'm a doctoral researcher at Bosch. I joined 6thSense later in December 2025 as doctoral candidate 10. My research focuses on fusing data from multiple sensors, including, of course, joint communication and sensing data, as a powerful 6thSense. Coordinating all these different information sources is a major challenge, especially when the environment is very dynamic, like in a busy traffic situation in a city. The ultimate goal is to improve situational awareness and autonomy. You want to do this using reliable, robust, and resource-efficient technology.
Our PhD students, or most of them, have been with us from between 6 to 12 months, and therefore they have started getting expert and more expert in their area of work.
I joined in April this year, and from the current stage I already finished implementation of a nice test bed.
So now we have very nice, lively discussions on what we can do next.
We have a lot of invited talks focusing on 6G, even beyond 6G, joint communication and sensing, AI, etc.
Our goal is to enable our everyday devices with another vision. Now, we've pursued this vision in 4 work packages.
And the first work package looks at different technologies and frequency bands for joint communication and sensing.
In work package 2, we go a step further and we consider the fact that these networks, our solutions, need to be implemented in practical networks as they are today.
Joint communication and sensing analytics, which is work package 3, and basically in this work package we want to get information out of the signals and do something relevant.
Now, to put everything together, a good solution comes always when you have a good use case.
This fourth work package is about our killer applications that we envision for joint communication and sensing. They can be healthcare related, automotive related, or related to smart factories.
Our bright students are going to put their minds together to take our solutions and adapt it to these particular use cases.
The communication signals that are of higher bandwidth, shorter wavelength, enable us to perform more fine-grained sensing, such as sensing breathing, heartbeat, and small and subtle movements.
So in work package 1, we are trying to figure out sensing across different parts of the spectrum.
Cellular communication is of course of very large strategic importance for Europe. We have been leading this field already since the 2nd generation, and now we're already talking about the 6th generation, so it's important for Europe to keep leading the innovation. And as joint communication and sensing is a very important topic for 6G networks, this project specifically is also very important for Europe.